So now let's discuss some clotting disorders. A thrombus is a clot that develops in an unbroken blood vessel. So it's internal to the blood vessel, and that could be because of damage to the internal part of the blood vessel, the endothelium, or aggregation of platelets, or it could be from fat blockage or atherosclerosis, which is narrowing and hardening of the vessel due to fat plaques. That condition or that thrombus can result in a thrombosis, which is occlusion of the vessel, and that's one of the problems that occurs in myocardial infarction or heart attacks. An embolus is a thrombus that's freely floating. If it occludes the vessel, we call that condition an embolism. Those that occur in the pulmonary circuit and the cerebral circuits may result in death fairly quickly, or in the case of a cerebral aneurysm or a cerebral embolism, it may result in aneurysm or weakening of the vessel wall and thus rupture. So now you watch an animation of the formation of a thrombus, an embolus, thrombosis, an embolism, and a myocardial infarction.
Because the heart must continually beat, the coronary arteries serve a critical role, supplying the constantly active heart muscle with oxygenated blood. As we zoom in to observe the interior of this diseased coronary artery, notice the partially restricted blood flow due to the atherosclerotic plaque in the arterial wall.
That is the thrombus right there. It's causing thrombosis, which is occlusion of the vessel.
If part of this plaque ruptures, a thrombus forms and may grow and occlude the vessel. The thrombus detaches, causing an embolism, obstructing the blood flow through the artery. Since the supply of blood has been obstructed from reaching the region of the heart supplied by this artery, the myocardial cells become ischemic, resulting in damage to the heart muscle. Symptoms of a myocardial infarction may include shortness of breath, tightness in the chest, intense prolonged chest pain, nausea, fainting, and intense sweating, pain in the left shoulder, arm, jaw, and back.
Some anticoagulant medications that you're likely to see in practice include aspirin, which inhibits thromboxane A2, that's a platelet aggregator, heparin, that's also an anticoagulant used routinely, and warfarin or Coumadin that interferes with the action of vitamin K that's required to manufacture 4 of your clotting factors. Thrombocytopenia, thrombo meaning the clotting cell, the platelet, cytocell, penia, a decreased number of, is a condition in which there's a decreased number of platelets, although this condition seems to be fairly rare and due to a major traumatic event such as bone marrow deficiency or disease, or potentially during pregnancy. An impaired liver can also cause disorders of clotting as well. The liver is required to make some of the clotting factors required in coagulation. It makes non-essential amino acids. It stores vitamin B12 and somewhat B6 for red blood cell production, although that would usually lead to an anemia. It also produces bile, and bile has a role in catabolizing fats, and since vitamin K is a fat-soluble vitamin, that can impair the ability of vitamin K to be absorbed or utilized properly. Now, disseminated intravascular coagulation, which means that it's within the vessels and widespread throughout the body, refers to the formation of sporadic or spontaneous clotting that can occur as a problem in septicemia, blood poisoning or infection of the blood with a microorganism, in a delayed, or I should say subacute hypersensitivity that occurs with transfusions or other parasitic attacks. So now we look at blood typing. What we're going to look at are the ABO blood groups, although there are several other factors, several other cell surface markers that designate blood type, but we're going to look at these 3. So your blood type can be AB, B, A, or O, and will also include rhesus factor, which is the positive or negative of your blood type. Most people in America have type O blood, O positive being most common, and very few, the least number, have AB or AB neg. So now we'll look at an animation that explains blood grouping, the agglutinogens or glutenins that are on the blood cells, and the antibodies that would be present in the blood cells. So again, agglutinogens are the surface cell markers, part of the glycocalyx on your red blood cells. And in that person's plasma, the liquid part of blood, we see antibodies that protect against foreign blood cells.
In order to determine blood type, we will visually centrifuge these blood samples to separate the blood components. The ABO blood group is based on the presence or absence of two major proteins in red blood cell membranes, agglutinogen A and agglutinogen B. A person can have A and B, or neither A nor B in his or her blood cell membrane. These blood types are referred to as A, B, AB, and O. If a person has type A blood, his or her blood will contain antibodies against agglutinogen B. These antibodies are called agglutinins. Conversely, a type B person will have agglutinins against agglutinogen A. Blood compatibility can be predicted by understanding the differences between the donor and recipient blood types. The donor's blood generally only contains red blood cells with no plasma. Therefore, it is agglutinins in the recipient's blood plasma that determine if the donor's blood will be compatible. For these reasons, type O is known as the universal donor, while type AB is known as the universal recipient.
And now, question number 25. What's the difference between a thrombus and an embolus? Question number 26. Aspirin, warfarin, and heparin all inhibit coagulation. Explain how each does that. 27. Explain how liver cirrhosis would affect hemostasis and erythropoiesis. So this is a blood typing test similar to what you'd be doing in the laboratory, but we'd also see a column here for anti-RH or anti-D, that's RH factor. So for a person who has type AB blood, they have AB agglutinogens on their cells, and in their plasma, they would have neither anti-A nor anti-B. So the blood typing test works on sort of the reverse principle, if you will, that if you apply anti-A to the person who has AB cells, you will see agglutination occur. That's clumping from the combination of antibody A and the agglutinogen A on that person's blood cell. And the same thing would happen with anti-B. If the person was anti-RH or RH positive rather, and you applied anti-RH solution, you'd also see agglutination with anti-RH. So the best way to interpret these is to look and see, yes, there is agglutination, and yes, there is agglutination here. So that person has A's and they have B's on their blood cells. Now, if we look at type O, this person's blood cells don't have antiglutinogene A or antiglutinogene B. So when we apply antibody A and antibody B sera, we see no agglutination, so no A's, and no agglutination, no B's. If they were RH negative, we'd also see no agglutination with the RH serum or anti-D serum. So that person would be no A's, no B's, no RH's, and O negative. So given that information, What antibodies would you expect to find in the blood of a person who is O negative? That would be question 28. Question 29. What antibodies would you expect to find in the person who is AB positive? And question 30. What's the difference between adult and fetal hemoglobin? Now at this point, you should also go back and review blood typing and cross-matching, as well as transfusion reactions that result from mismatched blood. This procedure is fairly simple, and it's one that you'll do in the laboratory. You'll also be able to see that type O is the universal donor, type AB the universal recipient, and usually blood types or blood transfusions would be for packed red cells, and then an isotonic solution would be used to restore fluid balance in the body. And in some cases, if you happen to be a rare blood type, say an AB pos or an AB neg, that person might donate their own blood before going into surgery, and that's called an autologous transfusion, self-transfusion.